Hi, in this video I work out a way to test the surface mount power supervisor I soldered up last video. This video includes a poorly formed voltage divider which skews my tests for a while. See if you can spot the problem before I do. Hi, my name is Adam. I'm building a 16-bit computer from scratch. I hope you'll join me on this journey. Okay, so how do I test this thing now? Well, I think the first thing I need to do is spend some time with the data sheet so that I can determine exactly how it's supposed to operate. So let's switch over to that. So this is a LP3470A device. And it's got a body size of 1.6 millimeters by 2.9 millimeters. I told you the thing was small. Let's see here, at 5 volts, which is what I'm planning on operating it at its normal operating temperature of 25 degrees. Excuse me. It looks like it'll pull about 0.27 microamp. So that's not too bad. Table of contents. Device comparison table. Okay, so there's several different devices. Which one did I get? So if I look here at what I ordered, LP3470A 463. 463 has a 4.63 volt threshold. But if I fall below that threshold, it's supposed to throw an indicator light. Okay. There's my pinouts and how it's supposed to be connected. All right, so reset time out. It uses a capacitor to drive that and gives me a formula. So the timeout delay is supposed to be 619 times the size of capacitor 1 in microfarads. If no capacitor is connected, leave this pin floating. Okay. 2 is a ground pin. 3 is VCC1. 4 is VCC. And 5 is my reset signal. So coming back to here, on this side are the 3 pins. On this side are the 2 pins. This one's going to be my reset. So let's bring a breadboard in here. Let's see here. I'm going to need a ground line, and I'm going to use these jumpers to hook this up. I've got a few of them up here off the top of the screen. Ground is supposed to be pin 2, so that's a real easy connection down here. VCC and VCC1 are supposed to be tied together. And normally I would connect this straight up to power, the power rail up here. But I'm going to need to, well, let's get to that. And then I need something that's actually going to drive an LED. I did not grab an LED. But I'm going to need something that's going to drive an LED or some kind of an indicator to show that it is actually in reset. Okay, so my LED, this is an open drain, so I need to provide power from this side. So this is a 20,000 ohm resistor. And then I'll tie power and ground together so that I've got everything working the way it's supposed to. And then I should be able to hook up power and ground here. And that does nothing. All right, so maybe a capacitor would be good to keep that timeout open for an extended period of time. Let me see here. Let's try a 1 microfarad capacitor. No, those are polarized. Let's go with something a little bit easier. This is a 0.1 microfarad capacitor. And I'm supposed to connect that from here to ground. Let's plug that in and give it a try. Okay, so I got a little bit of a delay there. Let's see, can you see that? Yeah. So the light comes on reset, so I can actually use this to control the reset. I put a little bit larger capacitor in there, and I should be able to okay, so there's a nice long delay there, so I can actually see it. Now, the next challenge is, how do I actually test how do I actually test the voltage drop? And for that, I'm thinking I probably want to put a voltage divider in. So if I have here VCC, and I put a resistor, this is a horrible resistor drawing, and then another resistor, and connect that to ground, the tap right here is divided by the size of the resistor between the two of these. So if I put a potentiometer or a variable resistor there and tap off the middle instead of the edge, so this tap then comes down here, and then there's my tap off to my power control. I should be able to vary the voltage based on where I dialed this, and at some point it should cut out, and then when I increase it again, it should cut back in. That's the theory. Okay, so I've got a couple of potentiometers here. Well, this is a 1 meg, and this is a 10,000 ohm potentiometer. And then this was a 20,000 ohm resistor. I've got a 15,000 ohm resistor. So let's see here. Question is where do I tap this? So let's set this up this way. I'm going to put power in on this side. And I should be able to put my middle tap here to the power rail. Well, the light's on. My resistor is too large here. Let's find a 1K. Okay, a 1000 ohm resistor here. This one's been cut down because I used it on a different project. There we go. I believe I want this on this side. There it is. No, I'm not getting in small enough resistance. Well, let's pull this off to the side here. Because this is handy. I'm just going to pull a second resistor out and connect that to the power rail instead. Because I'd rather experiment than do math. But that's not working right, so I think I'm going to have to figure out how to measure. So, let's get the voltage. And my voltage between my ground. Try to keep the camera in view here. And here, it's 0 volts. There it is, 4.39. Okay, I'm not getting a good connection here. Okay, 5.21. I'm going to try to hold these in place and turn this. Normally I would show all my troubleshooting steps, but I'm going to pause this here because I spend about 15 minutes going off in the wrong direction here. And all of it boils down to the fact that my voltage divider wasn't dividing voltage properly. I had things wired up incorrectly. I end up finding that later, and rather than subject you to 15 minutes of me doing the wrong thing, I'm just going to go ahead and snip this here and jump right to where I actually identify what the problem is. Okay, so I was doing some cleanup, and it occurred to me that while I was testing, I actually did not create a voltage divider. And so I want to reset up and kind of show you what I did wrong and make a correction and redo my testing. So what I had is I had my ground set here, and then I had my power connected here. And then the challenge was I have, if you look at this, I have power coming in here, connecting to this resistor, going over here to the one end of the variable resistor, and then I've got the tap in the center of this, and that then becomes the center of the variable resistor, becomes the power line. And that's not a voltage divider. Those are just resistors all wired up in series. To correct this, this should be connected to ground. And then I should be pulling a tap out of here into power. And that then is a proper voltage divider, meaning that I should be able to adjust this potentiometer, and at some point the light comes on. Now, looking at the voltages, let's get this in the shot here. Let's tap. Let me get a pin here that I can throw in the ground and make it easier for me to actually measure this. So this pin is in the ground, and then here I'm at 5.15 volts, but if I turn my voltage so now I'm showing a very low voltage here, 0.4 volts, and it's really not enough to even drive the LED. So the voltage forward isn't enough for the LED to trip. Now I'm finally getting enough for the LED to trip. So that's falling off very quickly here. Got to get above 3 point. So that's working exactly the way it was intended to. My test was actually what was flawed. So that's the long story short of this. So, now that said, I am going to move this over to the clock circuit breadboard when I have a normal size breadboard that I can put this on. This whole test harness over here will go away, including the pins here for measuring the output. So it's just these that'll get wired up. Again, this is working exactly like I had expected it to. This capacitor, and I can barely read it, but it's 1 microfarad. So that's a 1 microfarad capacitor. So I will keep that. And actually, that reminds me, I should probably go back to this calculation. It says that the time delay is, and I'm just writing this down on my pad here, 619 times C1, and C1 is in microfarad. So 1 microfarad, so is equal to 619 times 1. And then if I multiply that, that's obviously 619. The new measurement is in milliseconds. So it should be on power on just shy of 1 second that this is on, that the light is on. And that seems appropriate. That seems like almost 0.6 of a second, give or take. So that seems pretty good. Let me see if I can move some of these wires out of the way here. And that seems appropriate. So that's working. Okay.